Hello students, welcome to Akshara 8 Foundation. Myself I am Shiv Shankar, I am your physics teacher. So today we will be discuss the kinematics, displacement and distance. So in the last class we have completed basics of the kinematics, path, displacement that we completed there. So now today we will see the differences between the displacement and the distance. Okay. So first we will see the distance. So what is distance there? Distance. So the distance is nothing but the total length of the path. The total length of the path is called distance. Okay. The total length of the path. The total length of the path is called distance. Is called distance. Total length of the path is called distance there. Okay. So now the distance can be measured. Distance can be measured in meter, SI units. So SI unit of distance. SI unit of distance. SI unit of distance is meters. It will measure in meters. M. Okay. So now the dimensional formula. Dimensional formula. Dimensional formula. Dimensional formula of distance. Dimensional formula of distance is L. Okay. It is a scalar quantity. We have discussed scalar quantity and vector quantity. In the vectors we have discussed there. Some of the physical quantities will have both magnitude and direction. They are said to be the vectors, and some of the physical quantities they will have only the magnitude, there is no direction there. Okay. So that is called the scalar quantity. So this distance will have only the magnitude, there is no direction. Okay. Distance has only the magnitude, there is no direction. So it is said to be the scalar quantity. Okay. Scalar physical quantity. Scalar physical quantity. Scalar physical quantity. Scalar physical quantity. Distance is a scalar physical quantity. So next one is, it is always positive. It is always positive. It is always a positive. So there is no negative value. Distance always, it is a positive value. Okay. So this is about the distance there. Now we'll see there. Suppose, let us see here distance. How can we calculate it? So we'll see how can we measure the total length of the path. Suppose a body started from here, point A, and went to point B, C, and D, E, and F. Suppose, okay. So A, B, C, D, E, F. Okay. So now let us consider it is a 5 meters distance and 2 meters, 4 meters, 3 meters, and let us say 5 meters here. So now the distance of this path covered by the body can be written as here AF. AF is equals to, we can write here. So AB, sum of all the positions the body has traveled. Okay, we can write here AB plus BC plus CD plus DE plus EF. EF. So here we can add there AB value how much there, 5, and this is a BC is 2, and CD is 4 here, plus 4 plus 3 plus 5. So how much we get here? 7 plus 11, 14, 19. So here we'll get there 19 meters. So now the distance is called the 19 meters. Distance is called 19 meters. So like that we can find out the total length of the path. Total length of the path. Okay. So this is about the distance. Now we'll see their displacement. Okay. Displacement. Is it clear now? Distance is nothing but total length of the path covered by the body there. Suppose a body travel from one position to other position, then the total length of the path there. So total positions traveled by the body. Sum of the total positions traveled by the body is also called as distance there. So distance can be measured in meters, and the dimensional formula. Dimensional formula is nothing but any physical quantity represented by its fundamental physical quantities and their powers is said to be the dimensional formula. That is the dimensional formula. And here scalar physical quantity. Scalar physical quantity is the distance will have only the magnitude, there is no direction there, because here you can see that the direction cannot be specified in a particular, okay, in particular side. So there are many directions will be involved if we consider the distance there. So we can say here it has no direction, okay. So then the distance is a scalar quantity. So it is always a positive value there. So this is about the distance, and now we'll see their displacement. Now we'll see displacement. So next one is the displacement. Displacement. So displacement is also distance between the initial and final position. Displacement is the distance between the initial and final position, or we can say it is the shortest distance between the initial and final positions here. Okay. Suppose if you see here, a body travel from point A, let us say here from A to B and B to C and C to D there. So this is a B, C, D. So we know that A to AD will be the distance, AD will be the distance, and if you want to write a displacement, so that is nothing but from A to D, the shortest distance, this will be the shortest distance. Now AD will be the displacement, we can say this is the displacement there. A, B, B, C, C, D, that is the distance. Total length covered by the body is called the distance, and A to D, the line joining the initial position and the final position, that is called the displacement, we can say. That is the shortest distance. To move in a shortest distance, we have to go in a particular direction there, then only we will get the displacement, no, shortest distance. Then we can say here this is the displacement there. Displacement. Displacement. So we can define as here the shortest distance. The shortest distance. The shortest distance between initial and final position of an object is called, final position object is called displacement. Is called displacement. Okay. The line joining or the shortest distance between the initial and final position. This is the initial position. A will be the initial position and D will be the final position. So the distance between the initial and final position is AD. So that will be in a particular direction there. So that is called the displacement. Okay. See here, this displacement will be measured in meters. So now we can write here SI unit of displacement. SI unit of displacement is meters. So SI unit of the displacement is also meters because it is a distance, no, shortest distance. So it will be the symbol for the meter is small m. And next one we can write here. So that is a dimensional formula. So dimensional formula of displacement. Dimensional formula of displacement. Dimensional formula of displacement. Dimensional formula of displacement is, so meter node, SI unit is meter, so here we can add there L. This is the L there. So the length is nothing but dimensional formula of meter is the length. Okay, the symbol of the meter is here L. So we can add that it is kept in the bracket, that is L there, dimensional formula. And second one is, third one, it is a vector quantity. It is a vector quantity. It is a vector quantity. It is a vector quantity because the displacement has both magnitude and direction there. So suppose if you take here, this is a from A to D. Let us consider here 2 meters. If we consider here 2 meters, okay, then 2 meters in which direction? This is a east we can write here, and this is a north we can write. So now we can write here, we can represent the northeast direction, no? So northeast direction there. So like that, the displacement will have both magnitude and direction. So it is said to be the vector quantity, vector physical quantity. Okay, and displacement may be it may be positive value, may be positive, comma negative, and even 0 also. So it can be 0 also, displacement may be 0 also. Okay, so this is about the displacement. Okay, that is about the displacement. Okay, so we'll see some of the examples. And what are the differences here? So the differences we can see that here, displacement is a vector quantity and distance is a scalar quantity. And so this may be in positive, negative, and 0. Only the distance will have only the positive value, positive. And next, remaining similarities are there. Similarity is nothing but the SI unit of displacement is meter and dimension formula is also it is L there. Okay. So this is about the distance and displacement. Now we'll see some formulas there. Okay. So concept based questions are all definitions that you can answer there. See, first question is given here. Dash covered by a moving object is the actual length of the path covered by the object there. That is the distance. Okay. So first option is distance. Concept based question, see here. So first one is here. Dash covered by a moving object is actual length of the path covered by the object. That is called the distance. First one is distance there. So distance is a scalar quantity. And these are all the conceptual based questions. Now you can answer these questions. Now directly we'll go through the lecture's task. Exercise 1. Exercise 1. Multi-choice questions are there. First question you see here. If a body moves in a circular path and reach back its initial position, then, so body moving in a circular path. So we'll see the exercise problem. Exercise 1. So first question you see here. If a body is moving in a circular path, suppose it is started from here, and suppose it has in a circular path means it will have certain radius. If it is started from here means in a one round it will be complete and it will be come to the position A only. Okay. So then it will be come to the initial position then. So what will be here? The displacement will become 0. Distance will not become 0 there. Only the displacement will become 0 there, because displacement is a distance between the initial and final position. So there is no difference between the displacement now. So here d bar displacement will become 0 there. Displacement will be 0. So now in which option is there? That is magnitude of the displacement is 0, distance is 0. Both 1 and 2 are correct. None of these. So we can write first option. So answer is option 1. Okay, that one. Next, if the distance covered by the particle is 0, what can you say about its displacement? Distance covered by the particle is 0 means displacement is also 0 there. It must be 0. So second one is option 4. Option 4 is right. And third one you see here. If the displacement of the particle is 0, distance covered by it. Okay. So displacement is 0, distance covered by it. In this example, we can see here displacement is 0, but here there is a distance is there, no? Distance is present there. Okay. So now it may be 0 or may not be 0. So here answer is option 1. Option 1 we can write there. Option 1. So next one. A man leaves his house at 5:30 a.m. for a morning walk and returns at 6:15 a.m. The displacement is there. So he started from the home and came to home again. So the displacement will become 0 there. Displacement will be 0 there. He started from his home and he went out for the walking and he returns back to the home again, then the displacement traveled by the body is 0. So the answer is here option. Here we can add option 2. Fourth one is option 2. So 0. So here option 2. Option 2 is the right answer. Next, a particle completes a revolution along a circular path of radius smaller, the distance travelled by the particle is. Okay. So we can take the same example as we have taken here first one. Okay. This example we can take, fifth one we will see there here now. So they have given here the radius of the circular path is, or small r is given. If a particle is moving in a circular path, so in one complete rotation, then the distance travelled by the body. So it is started from A and one round means it has to become at point A there. Okay. Displacement is 0 there, we know that. And what is the distance? Distance is nothing but total length of the path, total distance covered by the body in its journey. So then here we will get there, this is a circumference of a circle now. Therefore, the distance is equals to circumference of a circle. Circumference of a circle. So that is nothing but circumference of a circle is what there? Distance. It is a 2 pi r. 2 pi r. So radius, r is the radius. R is the radius here. Circumference of the circle is 2 pi r. So this is the answer there. Now the answer is option here. In the fourth one, option is 2. Sorry, the fifth one. This is the fifth one. Option 2 is right answer. Option 2 is right answer. Okay. Next, sixth one, a man walks 4 kilometers towards east. Sixth one, you see that here. A man walks 4 kilometers towards east. East is. So the directions we have to see there here. This is the right side is east and left side is west. Upwards is north and southwards is downwards is south there. Okay. And this is 4 kilometers. And from there here, he has travelled north 3 kilometers north there. So right here, this is also 4 meters and it travel north. North means towards up no 3 meters. So A, B and C here. So this is the distance. In the right angle triangle, this will be the right angle triangle no? It is the right angle. ABC is the right angle triangle. From the right angle triangle ABC, we should apply Pythagoras theorem. So this is a 90 degrees. Opposite to 90 degrees, it is said to be the hypotenuse. And this will be the base. This is the base here. AB will be the base and this is the height. So it is a height. So BC will be the height there. So by using the Pythagoras theorem, what is that? AC is equal to AC square. AC square is equals to AB square plus base square plus height square. Base square plus height square. This is the AB and BC square here. Okay. So now from this AC square is equals to, we can write here 4 square. Now AB square is nothing but 4 and BC is nothing but 3 here. 3 square. So we'll get how much then? This is 16 plus 9. So then AC square is equals to, we'll get AC is equals to. So we write here AC. So if you send the square root that side, it will become, if you send the square here to other side, it will become the root there. So it will become 25. So AC is equal to root 25. Again root 25, we can write here 5 whole square. The square root and root will be cancelled, 5 will be the remainder. So therefore AC is equals to, we'll get here AC is equals to 5 meters. So AC is nothing but what? The displacement. The shortest distance between initial and final position. Initial is this A point and final is the C point. That is the distance we got here, that is 5 meters. That is the answer. Okay. So option is what here? Option is so they are asking here distance. Distance covered by the man. Okay. So now we got this is the displacement now actually. Now we'll see the distance covered by the body. Okay. This one, sixth one again we'll see there. They're not asking the displacement, they're asking the distance there. Okay. So your sixth one you see there. A man travels 4 meters east and 3 meters north. 3 meters north from here. So climbs to a pole 12 meters height. So climbs a pole means 12 meters height means like this. This is a 12 meters. They're asking the distance. Distance is this one. Displacement will be also this one. Means here A, B, C and D here. So this is given there 3 meters and these are 12 meters. Then AD will be the distance. Distance is nothing but sum of the all the positions there. So you will get here AB plus BC plus CD. So we'll get here this is a 4 plus 3 plus 12. So how much you get there? 19 meters. So AD will be the 19 meters. AD will be the 19 meters. So option is what there? Option 4. Distance covered by the man is here. So therefore answer is option 4. Option 4 is the right answer. Option 4 will be the right answer. So they are asking there seventh one, numerical ratio. So numerical ratio of displacement to the distance. Numerical ratio of the displacement to the distance. There is always one there because see displacement always it is lesser than the distance there. So then they are asking here the numerical ratio of displacement to the distance. So displacement to the distance it is the less than or equal to 1 always. So this is the answer there. Now the option is it is always less than or equal to 1. Maybe less than or equal to 1. We can write here option 4. Option 4. Option 4th one is right answer. Next, choose the correct statement here. It is given there. A body may travel some distance without having displacement. So we have seen there, that is a correct one. So a body may have, second one is given here, a body may have displacement without distance there. Okay, this is wrong. Displacement should be greater than the distance, it is wrong. And fourth option is given all of the above. So here first, second, third, fourth are all wrong there, only first one is right. So eighth one is, first option is correct, okay. Eighth one, first. Eighth one solution is first one. Option 1 is correct. Ninth question. A train moves 5 meters due south, 7 meters due west and 8 meters vertically upward. The distance traveled by the train is. Okay. So here the question is given here. A train moves 5 meters due east. 5 meters due east. Sorry, due south is given. So 5 meters due south. This is the south there. So direction is here. This is the east and north. This will be the south and here it is the west there. So 5 meters south, 5 meters south and from here west is 7 meters. West is 7 meters. Then here from this 8 meters vertically upward. Vertically upward means like this. Vertically upward means like this. So here it is south 5 meters. Then west 7 meters and from here vertically upward means like this 7 meters. So on the board it will be like this there. So that I will write like this. So now this they are asking their distance. Not this one, here total distance. A consider B and C and D here. So now AD can be written as here. AD is nothing but distance. Distance AD. So distance AD is equals to, we can write here AB plus BC plus CD. Okay, that is the distance now. So AB is what here 5, BC is 7 and this is what they given here 8 meters vertically upward. This is 8 meters. So we can write here 8. So how much we get there now? 12 plus 8. We'll get how much? 20 meters upwards. So now the distance is what here? Distance AD. AD is equals to 20 meters, it is 20 meters. Okay. Now the option is here. Option first. Option 1 is correct there. Option 1 is right. Completed now? Now 10th one we'll see there. Tenth question. Object moving from 4 meters to 7 meters. Object moving from 4 meters to 7 meters. So here 10th solution. So object started from, let us say, from the origin we consider there. It has moved 4 meters. Okay. And 4 meters to 7 meters. From here it will be 7 meters now. Let us consider this is A and it is B. OA and OB. OA will be the initial and OB will be the final. Then they are asking the displacement. Okay. So then displacement AB bar, modulus at a magnitude of AB bar. Okay, is nothing but, so we'll get there here OB minus OA. How much you get there? 7 minus 4, we will get there 3 meters. So this will become modulus of AB bar. It is the displacement. So now the option, what can we write here? Option 3. Option 3. Option 3 is the right answer. So now 11th one, we'll see here 11th one. The 11th question, what they have said there, object moving from minus 7 meters to 7 meters. Displacement is, okay. So this is 0 and here we can consider this is a minus 7 and here it is a B plus 7. This is a B plus 7. Minus 7 to plus 7. Okay. So then this is a final. We can add A to B, it has traveled there. It started from OA. This is the initial and this is the final there. The distance between that we can write here. OB minus OA we can write. OB minus OA. So then it is 7 minus of minus 7 we can write here. This is a 14 meters. So therefore AB bar, modulus of AB bar can be written as here 14 meters. Modulus of AB bar can be written as 14 meters. Okay, that is the answer for 11th one. Now we'll see the 12th one. 12th one. Object is moving from 2 meters. Let us consider 0, 2 meters, 2 plus 2, 2 plus 2 only. Here only then. What is the distance? Displacement between the initial and final position. Initial point is moving from 2 to 2 means here the displacement will be 0 there. Okay, there is no difference between the A starting point and initial final point will be same there. So therefore displacement will become 0 here. That is 0. Displacement will become 0 there. Then therefore option here we can write option 4. Sorry, option here it is 3. Option 3 is the right answer. There is no distance or there is no difference between the initial and final position. So it is 0. Next 13th one. Object moving from 5 meters to 2 meters. 5 meters to 2 meters. So here we can add there. So 0 to 5 meters it has traveled. 0 to, let us consider it is A and this is a 5 meters. This will be the 5 meters and then 2 meters. It has went 2 meters. This is A and B here. This will be the 2 meters. From here to here it is 2 meters. Now what is the initial here? Initial position. So displacement AB. AB will be the displacement now. So initial is what there? OA. 5 meters to, so OA will be the initial and OB will be the final. So we can write here OB minus final position minus initial position displacement. No? So OB minus here OA we can write. So therefore it is OB is 2 and here this is a 5. Then we will get there how much there? Minus 3 meters. So therefore AB is equals to minus 3 meters. AB is equals to minus 3 meters. Okay. Next, 14th one. 14th one is there. A man walks 8 meters towards east and 6 meters towards north. The distance traveled by him is. So 8 meters towards east and 6 meters towards north there. So they are asking only the distance. 8 meters towards east. East is like this, no? East. Right side is the east and upwards is north, downwards is south. Okay, and this is the west. This will be the west there. So we can write here. This is 8 meters east and from here north. North is 6 meters. Then this is A, consider B and C here. So this is the AC, no? AC will be the distance. So AC is equals to, we can write here, AB plus BC, no, distance. Distance. So that is equals to AC is equals to 8 meters plus 6, we'll get here 14 meters. So 14 meters will be the answer. Now the answer, correct option is what there? Option 2. Option 2 is the right answer. Option 2 will be the right answer. Now 15th one. In the above problem, magnitude of the displacement is. In this problem, what is the magnitude? Here 15th one will see there here 15th solution. From this problem only magnitude. Magnitude of the displacement they are asking there. Now the displacement is nothing but shortest distance between the initial and final position. Shortest distance is nothing but initial from here to AC and initial position. Distance between the initial position and final position. A is the initial position and C will be the final position. So displacement, to find out displacement from the triangle here, from the above diagram ABC we can write here. Then hypotenuse is equal, hypotenuse square is equals to AB square plus BC square, AB square plus BC square. So AC is equal to square root of AB square plus BC square we can write now. So square root of here, this is a 8 whole square plus 6 whole square. So now AC is equal to, we'll get here 64 plus 36. So we'll get here 100 now, 100. So 100 we can write here 10 whole square now. So this and this will be cancelled here 10 meters. Therefore AC is equals to, we can write here 10 meters is the displacement. So 10 meters will be the displacement there. Shortest distance between the initial and final position by using the Pythagoras theorem. Okay. So this is the Pythagoras theorem here. This will be the Pythagoras theorem. Hypotenuse square is equals to base square plus height square. So now numerical value questions we will see there. Numerical answer type questions. A car travels 10 kilometers towards east, then travels 5 kilometers towards west. The displacement of the car is. Displacement of the car. So numerical answer type questions. Numerical answer type. క్లాస్ చెప్తున్నాం వస్తున్నా క్లాస్ అయిపోయింది ఒక 2 ప్రాబ్లమ్స్ ఉన్నాయి వాళ్ళు అయిపోయిన తర్వాత వదిలే So 16th one, numerical type answer questions. 16th solution, see there. A car travels 10 meters towards east. So east means like this, towards east 10 kilometers, and from there towards west 5 kilometers towards west. Let us consider this is a A and this will be the B, east, like this direction, and then from here to here it is a 5 meters towards west. This is a west, this is a 5 kilometers. Then they are asking the displacement. Then displacement of the car. So car started from here, from initial position A and went to B, and it returns to point C there. This is the final position. So the initial position is A and final position will be the C there. Now the displacement is nothing but the shortest distance between the initial and the final position. That is nothing but here displacement will be the c. Displacement. So AC will be the displacement here. Magnitude of this displacement can be written as here. So how can I write there? So AB will be the initial distance and AC will be the final distance. So we can write here AB minus AC. We can write like this AB. AB will be the 10 meters, no? AB minus BC we can write here. AB minus BC. So AB how much there it is? 10 kilometers minus BC is what? 5 kilometers. So we'll get here 5 kilometers. So 5 kilometer will be the magnitude of the displacement. This is answer there. Shortest distance between the initial and final position. Seventeenth. A boy travels 2 kilometers towards north and travels 2 kilometers towards south, then total distance traveled by the boy. So 17th one, 17th solution. A boy travels 2 kilometers north. A boy travels 2 kilometers north. This is the initial position. You consider 2 kilometers north there. AB, this is 2 kilometers. And from there, 2 kilometers south. 2 kilometers south means again it will become to here 2 kilometers. The distance we can write here AB plus AB, no? Distance is AB. AB plus BA we can write there. AB plus BA. A to B travel and B to A again travel there. So we can write here 2 kilometers plus 2 kilometers. So we'll get here 4 kilometers. So therefore distance AB is equals to 4 kilometers. Distance AB is equals to 4 kilometers. Okay. So last problem, 18th one. The position of the particle is going straight line is x is equals to 50 meters at 10:30 am and x is equals to 55 meters at 10:35 am. The displacement between the 10:30 am and the 10:35 am is, okay. So position of the particle. So let us consider here origin. It has started from origin, you consider there, and it went to position A, first position, x is equals to 50 meters. X is equals to 50 meters. This is a O, and let us consider this is a A position. O to A, it has traveled there 50 meters in 10:30 am. It has traveled 50 meters in 10:30 am. This is a 10:30 am. 10:30 am. Okay. And 10:35 am. So A has traveled x is equals to, from here it is how much? Up to here, that is the x is equals to here 55 meters. 55 meters. So up to here, this is considered B there. So this is at 10:35 am. 10:35 am there. So now they are asking the displacement between 10:30 am and 10:35 am there. Okay. So what we have to do there? We have to subtract final position minus initial position. So what is the final position is here? OA, no? So AB, they are asking there, AB will be the displacement. This is the displacement. Displacement between 10:30 and 10:35 am. So AB is equals to, final position is what there? It is a OB, and initial position is what there? OA. So there is a difference between the initial and final position is nothing but the displacement or the shortest distance, no? So we write here is a 55 meters minus 50 meters. We will get there 5 meters. So therefore, the magnitude of the displacement is 5 meters. Magnitude of the displacement is 5 meters. Okay, that is about the this first synopsis. Second synopsis is completed. Then tomorrow we are going to see the next class. In the next class, we will start the next synopsis. Okay.